All right, you want to take out your textbook. Start at page 424, page 424. And last night for homework, I asked you to do numbers 1 through 15, the odd. We were working on adding fractions together. And I said yesterday, had you write this in your notes, that in order to add fractions, Maddie, you have to have a common denominator. Now, in this lesson, all the denominators are already going to match. Starting tomorrow, we'll begin looking at equations where there's not a common denominator. We're going to, or addition problems where there's not a common denominator. And we're going to have to get that common denominator. But for now, denominator's already going to be the same. So basically, Noah, all we would have to do is add up the numerators. And remember, you keep the denominator. So the mistake that you see most commonly among people who don't understand math is they would say 2/3 plus 2/3 is 4/6. No, it's 4/3. You just keep that same denominator. So in number 1, for instance, where we had 8x thirds plus 2x thirds, Noah, we simply add them to get 10x thirds. No big deal at all. Maddie, on number 3, we had 8x negative 1 sevenths plus 9x positive 3 sevenths. Now here, like Noah's problem, we do add the numerators, but we're only going to combine the like terms. So when you added the x's in the numerators, you got 17x. And when you added the nothings, the constants together, you got... So your answer was 17x plus 2 over 7 is correct. 17x plus 2 over 7. Number 5 is a subtraction problem. And we didn't get into this too much, but I want you to very quickly to look back with me. I'm sure you figured this out anyway, but let's look very quickly at page 423. Ran out of time yesterday as we were looking this over in our last lesson. But in order to subtract expressions, we would simply add the inverse. I'm sure you figured that out, right? So as we look at example 11.5e, 4 over x, negative 3 over x, or minus 3 over x means 4 over x plus a negative 3. So it's 4 minus 3, or 4 negative 3 would give you 1 over x. Looking at the next example, 3x over x plus 1 minus 4 over x plus 1 is really 3x over x plus 1 plus a negative 4 over x plus 1. Well, those aren't like, so you can't combine them. So you're just going to leave 3x negative 4 over the x plus 1. Do we understand those examples? Look at the next page. This is where it starts to get a little bit dicey. I'm curious to see how we did on the homework. I don't think we had any that would go quite this in depth. But look at the next example, 11.5g at the top of the page. We have a 2x plus 1 over that denominator minus x plus 2 over that denominator. I want you to skip down to the third line down. Do you see how they just put everything over the big denominator? The 2x, the positive 1. Now notice, a negative x and a negative 2. Do you see that both signs from the x plus 2 have changed? Because we're adding the inverse. Then they combined to get the x negative 1. But you could reduce that one because that denominator would factor. And you could cancel the factors of the x negative 1s, leaving you with 1 over x negative 3, where x cannot equal 1. You understand that example problem? Now this next one, number 5, didn't go that in depth. No, it was a 3 over 4x. Minus or negative 1 over 4x should give us 2 over 4x. But we're not going to leave 2 over 4x as our answer, Noah. Instead, we're going to reduce it down to 1 over 2x. So initial answer, completed answer. Did you both get at least the initial answer? Did either of you get the completed answer? You did. You just forgot to reduce it. But you see it now, obviously, because you just helped me with it. All right, great job, Maddie, for catching that. Number 7, when we added those together, what did you get for your answer, Maddie? Good, 2x negative 1 over 2x. Number 9, Noah?
6x squared negative 6x squared over x.
Ah, careful. Only combine like terms. We have a 6 negative x squared x over x plus x squared negative 6 over x. The key here, remember, is you're basically going to keep that denominator. And this is a strategy we're going to use as we get into more involved fraction problems. But what I like to do is just do one big long fraction bar, just put the denominator down there, and then recopy everything else. We're going to combine the negative x squared with the x squared.
0.
Cancel, right? 0. And the 6 with the negative 6. So our numerator is,
1 over x.
ooh, careful. We didn't cancel by cancellation. We actually added to get 0 plus 0 over x, or in other words,
0 over
and 0 divided by anything equals,
0.
and there's our answer, 0. Did you happen to get 0, Maddie? Does it make sense now why we would have? Does that make sense to you as well? And I like that when I said when you add the negative x squared to the x squared, what do you get? And you said 0. Because they do cancel to give you 0. Same as the 6 and the negative 6. Now, a 6 over a 6x, when they cancel like this, that leaves you with a 1 and a 1 technically, right? But canceling by subtraction gives you 0. Canceling with division gives you the 1. Number 11. Pretty straightforward, I think. Maddie, what did you get? Good. Again, those numerators don't combine because they're not like terms. So you keep the x and a negative 5 over the x plus 3. So x negative 5 over x plus 3. Great job. Did you happen to get that, Noah? On number 11.
No.
What did you get for your answer?
Negative 5x.
Okay, so what you're trying to multiply those together. Again, it's just adding the x and a negative 5, which since they don't combine, we're just going to leave it. And again, we hadn't really gone over much of this, so if you had the struggle, I totally get it, right? So I'm just curious. This was more of a, I'm curious to see how well they pick up on this. Maddie picked up on it pretty well. Great. You're going to, right? And so I don't know that you're really even at a disadvantage per se. Number 13 is kind of interesting, Noah. Initially, careful here. So amending what you probably did in your homework, when we had x plus 4th, plus 4x plus 4, what would that give us initially?
X plus 4 over x plus 4.
Right, x plus 4 over x plus 4. But wait a second, what's going to happen now?
It equals 1.
Yep, we can cancel it away and just get 1. So initially, yes, x plus 4 over x plus 4, but it can cancel to give us a 1. The book would argue we should say x can't equal negative 4. What x exactly? Number 15, what do we get for our answer there, Maddie? Oh, you kind of combined what you had been doing correctly with what Noah did incorrectly. You multiplied your 5x squared with the x, but we're just adding them. A 5x squared plus an x, but are those like terms? So they don't combine. So our answer should have been, there we go, 5x squared plus x plus 1. It's a trinomial now, all over just x negative 10. All right, as we've gone over this, you hadn't really had any good full instruction. We looked at some example problems, that's about it. But you really hadn't had a whole lot of instruction. It was more of a, I wonder how well they could figure this out. Some of them we did, some of them we didn't. Does it make sense a little bit more now that we've gone over some of these? All right, I want you to tackle a few more of these and see how well we picked up on these as we were just going over it. I want you to do numbers 2, 6, 10, 14, 24, and 26. 2, 6, 10, 14, 24, and 26. So 6 problems. Shouldn't take you real long. And we're there on page 424. By the way, Gavin and Brecken will understand the weird mismatched outfit. It is tacky day, but if someone random happens to be watching on YouTube, I have not lost all fashion sense. It is specifically tacky day. We are supposed to look awful. You should see Noah. He looks about like normal, actually, but I'm just kidding. Anyway, Brecken's like, I ain't showing up for that. Noah Nadasky will save me. Anyway, so, pardon the strange appearance. let's take a look at these together. Again, this is not something you have to do, but I'm going to show you a method that if you're struggling in any way, should help you overcome the problem. What I'll do with every addition problem right up front is start by just drawing one long fraction bar. Put the denominator down below it, assuming you've got the common denominator. The numerators can just copy straight down. I think if you will do this, the next step should be painfully obvious. We've seen stuff like this since the beginning, first couple weeks of the school year. You combine like terms. 5x and 2x class combines to give you 7x. 3 and 6 combine to give you 9, thank you, Maddie, all over the 5. And again, by putting the LCD just once, it prevents you from trying to add them together. The next thing you try to do is, can I factor and cancel anything? Well, nothing factors, so nothing cancels, so I can't reduce, I'm done. I assume we have this answer for number 2. Now, anytime you've got a subtraction, and again, it seems almost pointless here, perhaps, because it's such a simple little problem, but a can't miss, never fail method is anytime you have a subtraction problem, change it to adding the inverse. And everything, and again, I know there's only one thing in this numerator, but everything in this numerator is going to change. In this case, the 4 changes to a negative. And again, you could take that same approach. Put the least common denominator below one long fraction bar and simply copy the numerators, the 2 and the negative 4. And here we get, of course, negative 2 over 7x. However, minus a point. Thoughts, Maddie? Pull the negative out to the front, and there's our completed answer. I assume we got this answer for this problem. Question, what did you have?
I didn't have the negative.
You just had the plain old 2. Do you see the 2 and negative 4 would give me then the negative 2? All right, otherwise good to go. And then Maddie, you had that. All right, looking at the next one, again, I'll start by drawing class 1 long fraction bar. Below it, I just write 2x. Again, that prevents me from trying to add them. And then above the fraction bar, I could just copy everything down. So what might I write above the fraction bar? If I'm doing it the slow, careful way. Again, do you have to, on an easy problem like this, necessarily do this? No. But if you've had any struggles, this method will work. What would I copy down above, Noah?
5 negative x plus x plus 8.
All right. And we see here a negative x and a positive x. Ding! Those are going to cancel. So really it's just 5 and positive 7 over the 2x, which would give me then
12.
But I'm not going to leave my answer as 12 over 2x. Instead,
6 over 1x.
It's 6 over 1x or just 6 over x. Did either of you have 6 over x? Great job. So both of you reduced that one. Excellent. Maddie, here, start by drawing a long fraction bar. Underneath it, put. Above it, put. Did you see? I was like, I think I might have misheard something there. Now, nothing combines this time. That's okay if nothing combines. But unlike here where we looked at it and said nothing factors, so nothing cancels, here, Maddie, we can factor. So we should go ahead and factor this into. And of course, the denominator we could just group as a single x plus 1. And when we do, we can. And that leaves us with technically over 1, but I don't need to put it over 1. However, we did lose our denominator. So I also need to specify, Maddie, that x cannot equal negative 1. And we'll include that with our answer. Did either of you get the final completed answer? Did we just stop right here? All right, look for opportunities. It won't happen that often, but look for opportunities to factor and then cancel at the end. Again, here you couldn't, here you couldn't, here you couldn't. Well, there you happen to be able to. Looking at the next one, Noah, let's start by drawing a really long fraction bar. Down below it, we'll put
a squared and b squared.
And above it, we can just write out
A squared plus ax plus bx plus ay plus by negative a squared.
and not a whole lot combines except for the
A squared.
and negative a squared, which technically don't combine, they sort of cancel away, so we don't really need to worry about those. As I look at what's left over, I've got 4 distinct, dissimilar terms, unlike terms. With those 4 terms, though, I could factor by, since there's 4 terms, grouping. I could look at just the first little group, factor out n,
X.
to leave me with,
A plus B.
and then in the next little group, factor out the,
Y.
to leave me with.
A plus B.
So then I suppose our numerator could then be rewritten in factored form.
X plus Y. A plus B.
Good, we've got the common factor of a plus b. Normally I pull it to the front, but it's not wrong to leave it behind since multiplication is commutative. Pull out the a plus b, that leaves us with x plus y. While we've factored the numerator, let's also factor the denominator.
A negative. Positive. B.
Right, sum and difference, a plus b, a minus b, and yes, we can cancel away the a plus b's to leave us with an answer on number 24 of x plus y over a negative b, where a cannot equal
B.
negative. Well, sorry, it was a positive right there. You can kind of see it up there. Negative b. You had it right first time. And there's our answer. Did either of you get this? Did we get that? Ooh, you didn't even get that?
Well, like, I factored the top, but then I didn't factor the bottom.
Okay, so you had x plus y, a plus b over the a squared minus b squared. So the difference of squares didn't scream at you to factor it?
Well, I was going to, but then I didn't know if it was right.
Oh, okay, yes, yeah. So basically, Maddie, just like if we had like 2 tenths plus 3 tenths equals 5 tenths, you have to reduce the fraction. Well, we've been working on reducing fractions, right? That was what we did a few lessons ago, was reducing, factor and cancel. So once you've done your addition problem and gotten your answer, factor and cancel, reduce it down. All right, I'll tell you what. Take a look at number 26. Number 26. Once again, I'm not going to write the problem down this time, but I'm going to start working the problem by drawing class A. Long fraction bar. This one's going to be really long because there's 3 fractions. But below the long fraction bar, I simply put A. What do I copy above the fraction bar? Maddie. Nice and loud, please. Careful. What's in front of the last fraction, Maddie? A minus sign, right? And we never really subtract, So in that third fraction, looking at it there in your books, that final problem on the page, the final fraction on the page, every single sign in that numerator has to change because of the subtraction. So not negative 5a, Maddie, but, and then, good. Does that make sense? Do we see how that works? Changing every single sign in the subtraction problem. Hold on.
Did you get the text from my wife?
I didn't.
Okay. Well, Miss LaFleur was sick.
Uh-oh.
That's from him. I don't know why
Maybe
he
he
didn't.
slept in because he wasn't feeling well. All
I
right.
didn't text you, but my wife did text you.
Okay. All right.
That's from him.
Thank you for running that up, Jim. All right. We now return you to your regularly scheduled programming. All right. So, questions on this with the adding of the inverse. All right. Now it's time to combine some terms. Noah. Now that Maddie's doing all the hard work. That's what guys do. Let the girls do the hard work that we pick up. Anyway.
The negative and positive.
The negative m and positive m's cancel.
And then the negative and positive n cancel. And then you're left with 7a over a.
So are we done? 7a over a? Maddie?
Oh wait, no. Yeah.
Girls to the rescue. Got to cancel the a, so we're just left with 7. And we could say that a can't be 0, but we don't really have to say it because there's not an a left over anyway. We don't need to say anything about these because these weren't factors that canceled. They were terms. Now, it's not in a multiplication problem. It's not in a reducing. They're terms within the same numerator. It's just combining like terms. But because they canceled through an addition process, we don't need to set them on equal to 0. And 7 should have been our answer. I'm guessing we probably did not get that answer. Does it make sense, though, with the subtraction? Let me have you do a few more of these then. Let me have you do number, strategically pick here, do numbers, let's do 17, 19, 21, and 23. 17, 19, 21 and 23. We'll just do some odd problems here. Again, on page 424. All right, for sake of time, let's go and take a look at these. Number 17, first of all. We'll draw the long fraction bar. Down below it, Noah put.
X plus A.
Up above it, Maddie put. There we go. And I like, we can do the plus 1, plus 2 in our heads, right? So I like that she went plus 3. I was about to say, if you said plus 1, plus 2, I was going to say nothing wrong with that, but something that easy, go ahead and combine. I should check to see if I can factor and cancel. Does this factor, Noah?
Oh, no. Yes.
Yes. Let's factor it, Noah.
X and X.
Now, this is the only way you could split it up, right? So if the outer inner doesn't check, then okay, well, I guess we can't factor it. But I would try to factor when you see this quadratic-looking trinomial. Does the outer inner check? Yes. And not only that, but the factoring helps us. Now, if the factoring doesn't cancel, what was the point of factoring, right? But if the factoring does allow you to cancel, then it was worth it. So my answer should just be x plus 1, where x cannot equal. And there we go. Did you leave it as x squared plus 4x plus 3 over x plus 3?
Well, I got 2x plus 4 plus 3 over x plus 3.
2x plus, on number 17?
I don't know where I got the 2x from.
Not either. All right, Maddie, is this what you got for number 17? That's not what you got either. Did you got this far? You didn't think to can't factor? Does it make sense? When you see that quadratic look, factor. All right, let's take a look at number 19. Down below the long fraction bar, Maddie put. Above the long fraction bar, Noah put.
2x squared negative 26.
Good, and again, if you can combine in your head, that's fine. Just be careful combining. Make sure you combine accurately, and he did. Now, there is something I can factor, Noah.
The 2.
The 2 to leave me with.
X squared negative 13.
Does this continue to factor?
No.
No. Do the factors, either of them, cancel with what I have here, class?
No.
Then did the factoring help me in any way? No. Now, if you take the time to factor, you could go ahead and leave this over this as your answer, but I would be fine with this over this as well because the factoring didn't help anyway. And frankly, I think we're smart enough in our heads to see that's going to be an x squared negative 13, which isn't going to factor further, so nothing's going to cancel anyway, so I'm not going to waste my time. Does that make sense? That's the lazy mathematician in me, looking ahead and being like, I already know what it's going to factor into, and it ain't going to factor far, and nothing's canceled with an x plus 5. So why would I waste my time? And there's the laziness. But either this over that, or just leave it as it is. Did we get this answer for number 19? You factored before you tried to just add them up and then do the factoring and reducing at the end. You try to reduce early, and that actually could mess you up, right? For instance, if I had 4/6 plus 5/6, Maddie, then, ooh, Mr. Jesky, I can reduce, make that 2/3. Okay, now, add 2/3 and 5/6. Oh, they don't have a common denominator anymore, do they? And so now you can't add them. So just once you have the common denominator, just do the addition, and then if you can reduce at the end, like here we could, do that later. Does that make sense? All right, let's take a look at number 21. Maddie, under the long fraction bar, we're going to put. Now here's where I'm going to recommend we don't try to do too much in our heads. Maddie, what should I copy above the long fraction bar? Excellent job. Change all the signs. I would show that step. Then do the combining. What do we get when we combine now, Maddie? Good. The only things that combine are right here. That gives me +1. Well, I've got an x squared negative 7x positive 1, which doesn't factor, so I'll group it, over x squared negative 7x positive 1, which doesn't factor, so I'll group it. And what's my answer, class? 1. As you cancel away those matching trinomials. Did either of you get 1 for this one? You did, you did not. Does it make sense now? All right, Noah, number 23, draw a long fraction bar. What goes under the fraction bar?
2x squared negative 10x plus 4.
Now, as I'm writing it, I know I can pull a 2 out of this. And I bet I can backwards FOIL it. I'm not going to worry about it yet, though. Make sense? I'm just going to hold off on that. But I'm thinking in my mind, this looks factorable. I need at the end to see if maybe there's some factor and cancel I can do. So that's thinking ahead. What do I copy above the line? Don't do too much.
3x squared negative 4x positive 1. Negative x squared negative, positive 4x negative 13.
There we go. For starters, just combine, or just copy down with all the signs changed. Now, let's go ahead and combine some terms.
3x squared and the negative x squared.
To get
2x squared. And then the negative 4x and positive 2x get negative 2x. And then negative 13 positive 1 get negative 12.
Now again, there's going to be a temptation here to cancel the 2x squareds. Those are terms. Do not cancel terms, cancel factors. The 12 and don't cancel those. But this, like the denominator, looks like, for instance, there's a common factor. And looks like maybe there could be some backwards FOIL as well. Noah, how do we factor the numerator? Start by pulling out the
2.
to leave you with.
X squared negative x negative 6.
That does look like it'll backwards FOIL.
X and negative positive 3 and 2. Yeah, 3
And check that out or enter, is that right?
2. Yes.
Yes. Maddie, down in the denominator, I can also pull out a common factor of, to leave me with initially. But that also looks like it'll backwards FOIL into. Negative 6, negative 1 is negative 7. Ooh. All right, double check. That time it really is a yes. There we go. And once I factored, now I can cancel. What cancels away here, Noah?
X negative 3 and 2.
So my answer, Maddie, there we go. And there's our final answer. Now, Maddie, you were still working, I think, on that last one when I stopped you. Questions on it? All right, does it make sense how you should have finished it out? Because we're going to practice some of these for homework tonight. Noah, you did finish this one. How'd you do?
I got it right except for the x cannot equal positive.
Wow, so everything except just forgot the excluded value at the end. Wow, fantastic job on that one. Good. You get some practice with that tonight as well. One thing I want to kind of preview, though, as we lead into tomorrow, because I keep saying it, we've already got the common denominator, but you know as well as I do, we are not going to keep getting these Christmas presents, right? Common denominators. We're going to have to figure out common denominators. But in figuring out a common denominator, that means you would have to change your denominators. So I want to look at that today, changing a denominator, kind of preview what's coming. Changing a denominator to make equivalent fractions. Changing a denominator to make equivalent fractions. Changing a denominator to make equivalent fractions. I want to start you off with your old days of long ago, right? Your elementary days. I want you to write down everything I put on the chalkboard because it'll be a good example to you. 2/5 equals how many 15ths? When you were in elementary school, you would have asked yourself, well, what times 5 would give you a 15? And class, you would answer yourself and you would say 3. And so you'd multiply the 5 by the 3, but you'd also multiply the 2 by the 3 to get 6. So you've made an equivalent fraction, 2/5 and 6/15. Really what you were doing mentally was you were saying, this is 5 times 3. Oh, here's the 5, I'm just missing the 3. How about this? 3/4 equals how many 20ths? Well, obviously 20 could factor, class, into 4.
Good morning, Crusaders. We have some results from yesterday's spirit change.
Interrupt this
In
broadcast.
5th place is 7th grade. 4th place at this point is 4th grade. 3rd place is K5 Mrs. Holt. 2nd place is 3rd grade. And 1st place is 2nd grade. You guys have a great day.
Way to represent 7th grade. All right. fact is, 20 can be factored, class, into 4 times 5, right? So obviously here's the 4, we're missing the 5, so we'll multiply the 3 times the 5 to get 15, right? This is what we did in days past. Write this one down now. 3 over A equals what over AB? Now here, I've already written the factors out for you. AB. Here's the A. Obviously, what's missing, class? The B. If you multiply A times B, you get AB. So we multiply the 3 times B to get 3B. Does that make sense? Now you might look at it and say, ooh, you can reduce. Well, duh, you could reduce. Of course, you get what you started with, right? So don't reduce. The point was to get the equivalent fraction. How about this? M over X equals what over X cubed? Now again, I don't know that you necessarily need to write this, but you should be able to think, well, X cubed is X times X squared. So that means the X was apparently multiplied by an X squared. So the M also needs to be multiplied by to get mx squared, if we want to keep it in alphabetical order, right? Mx squared, right? So that's what we're going to be doing here. How about with polynomials? X over m plus n equals what over am plus an? X over m plus n equals what over am plus an? Well, clearly this is the quantity m plus n multiplied by a. So here in the denominator, apparently I multiplied it by an a. So in the numerator, I also need to multiply by a to get ax. Do you see what we're doing here? You're finding what changed in the denominator. I had the m plus n. Stay with me. Here I've got an a m plus n. I just need to multiply by the a. One more, and then we'll call it good. 3n over a, 3n over a, excuse me, equals what over a squared plus ab? 3n over a equals what over a squared plus ab? Well, if I were to factor a squared plus ab, what would it factor into? Maddie? A times a plus b. Well, here we already had the a. So obviously, class, we multiplied it by, and if we did that to the bottom, then we also have to do it to the top to get 3n a plus b, or 3an plus 3bn. Make sense? I'm going to have you try just a few of these for homework tonight. Just a few of these. Page 427. Page 427. Numbers 11, 12, 14, and 15. Page 427. Page 427, numbers 11, 12, 14, and 15. Sorry, trying to multitask and doing a lousy job. Page 428, numbers 7 through 12, review. Page 428, numbers 7 through 12, review. All right. The 7 through 12 is practice with what we were working on earlier with adding fractions with common denominators. The page 427, 11, 12, 14, 15 is a little bit of practice with changing numerators to make equivalent fractions. We'll look at all of that in our next lesson. Have a wonderful rest of your day.